Hey guys, so today we're going to start our new unit. And yesterday, if you did your daily question, it said for you to, in your notebook, write down the difference between a hypothesis, theory, and a law. I hope that you did that. Did you? Because if you didn't, you might want to go do that right now because I'm fixing to go over it. So hopefully, you know the difference between these three. And if you don't, I'm going to tattle to Mr. Butler, Mrs. Schaefer, and Coach Bearden. So you should know the difference between a hypothesis, theory, and a law. Okay. A hypothesis, that's the one typically that you guys get right. It's a testable statement about an observed phenomenon. Usually a hypothesis is an if-then statement, and a hypothesis should be the starting point for further investigation. So you see something happen, some sort of weird phenomenon, and you say, well, I believe that if this occurs, then this will happen. And then the best thing you do from there is just go test it. You do an experiment to test your hypothesis, okay? A law, we're going to skip to a law. We're going to skip what we normally think is the middle one, and we're going to save theory till last. But a law is just a rule of nature, okay? Something that you observe in nature that happens pretty much the same way every time. And it happens so methodically that you can actually make predictions about other things and that they would act in a similar pattern. Laws tend to explain how something works, but not necessarily why. Okay, and laws cannot be changed. Once it's a law, it should happen that way every time for that particular phenomenon. Okay, so let's talk about a theory real quick. So I want you to understand that a theory is a well-tested explanation. Okay, a theory has been tested multiple times, usually by multiple scientists. It's been confirmed by multiple sources. Theories will try to answer the question as to why something occurs in nature. Why did this happen the way that this did? Okay. Why does this occur? Theories can be changed. They can be modified. They can be added to. They can be completely thrown out if they're found to be inaccurate. Dalton's atomic theory was one of those that was changed because new evidence was introduced. Okay. It wasn't completely thrown out because Dalton's theory, most of it was right. He was right about most of the things about atoms, but there were a couple of parts that had to be modified when new evidence was introduced in the 20th century that had to do with splitting an atom. So theories can be changed, which brings us to this. Over the next couple of weeks, we're going to be talking about our universe, origins and evidence. Last year when we taught this for the first time, this was a little bit controversial. And I had a couple of kids that I think felt uncomfortable with it at first, but I want you to understand that we're talking about evidence that has been introduced, and scientists will try to create connections between pieces of evidence, and they've created a theory. They've created a couple of theories about how the universe was created. Okay. And with a theory, you need to understand that a scientific theory is one that is a well-tested explanation. Okay. This is not just something that, oh, well, it's just a theory, so obviously it's not true. You can't just discount scientific theories that easily. Okay. These have been well tested. And all we're going to do is we're going to look at evidence that has been found in the universe. And we're going to talk about one of the theories in particular, the Big Bang Theory. Okay. Not only a great television show, but a really interesting theory about how the universe originated. Okay. This is the explanation as to how the universe began. The universe began as a single point, according to the Big Bang Theory, or an inflation. Okay. And that from that single point, the universe continues to expand outward in all directions. Okay. The evidence that we're going to look at over the next couple of weeks, we're going to look at light spectra evidence, and I'll talk more about that later. We're going to talk about the motion of distant galaxies, the fact that they keep spreading outward and outward and outward. And then we're going to talk about the composition of matter in the universe. Okay, what do the elements tell us about the origins of the universe? Okay, so we're going to be looking at all this. So hope you find it interesting. I really did. So, all right.